Welcome back, everyone. In this lecture, we're going to talk about histograms again, and we're going to continue our discussion with two additional topics. The first one being histograms on a masked portion of the image, and the second one being histogram equalization. As we mentioned in the previous lecture, we can actually select a specific region of interest and only calculate the color histogram of that masked section. We're going to show you how to create a mask and then achieve that effect. That should be just kind of a brief little overview of applying the mask and then calculating the color histogram. The larger part of this lecture is histogram equalization. And histogram equalization is a method of contrast adjustment based on the image's histogram. Previously, we saw how we could use gamma correction to increase or decrease the brightness of an image. Now we're going to show you how to increase or decrease the contrast of an image through histogram equalization. Here we have a little figure, and on the left it shows what the original histogram or color histogram of the image looks like, and we're essentially going to flatten it out or equalize it. And we're going to walk through an example of what that actually looks like. So here's an example of an original image. It's essentially just a bunch of grays. So on the left here we have the actual color values, and then in the middle we have just this small image. There's not really anything there, it's just a little white circle with lots of gray around it, and then we see the original color histogram. Something to note here is that the histogram for this original image, it doesn't have any values at 0 or 255. So it doesn't have anything that's pure white, and it also doesn't have anything that's pure black. What we're going to do is apply histogram equalization, which is going to reduce the color depth. And what we mean by reducing the color depth is you're actually reducing the shades of gray. Or if you're working with a particular color channel, then you're reducing the number of in-between colors between 0 and 255. So again, take a look at the original minimum and maximum values in this array. I've highlighted them here for you. Currently, the minimum value is 52 and the maximum value is 154. What we're going to do now is apply histogram equalization, and definitely check out the resource link in this lecture for the full mathematical breakdown of how this actually works. It works for a cumulative distribution function, but right now we're just concerned more of the effects of applying histogram equalization. So after you apply histogram equalization, notice what happens to those left values. That minimum value that was 52 now gets transformed to 0, and that max value, which was 154, then gets transformed to 255. And let's take a look at what happens to the actual image itself. So notice it's kind of just this blurry, almost gray, almost white circle there. And now it's clearly been high contrasted so that the circle in the middle is clearly now white, and then we have a clear border or edge. And the histogram is also now more flattened out. And now it extends all the way from the minimum possible value of 0 all the way to the maximum possible value of 255. So notice again how the min and max values have now been equalized to be 0 and 255. We also now see less shades of gray, so this results in a higher contrast. Let's see now the results on a normal image. So here we have a left-hand side image of just some hills with some trees on them, and then we have the actual histogram. So the red represents the histogram for those grayscale values, and then the black line represents the cumulative histogram there. And essentially what that does is it just keeps adding things up as you go towards the max possible value. And if you apply histogram equalization, what happens is the cumulative then becomes kind of this linear step function, and we get much higher contrast in the actual image. Again, we're going from something with low contrast, and if we apply histogram equalization, then we get something with high contrast, and we've also flattened out that histogram a bit. Keep in mind, we don't make the histogram perfectly flat. Instead, what we really focus on is making that cumulative process. So if we take the corresponding histogram in red versus the cumulative histogram in black, we take that cumulative histogram and make that much more linear than before. So that's the actual real process, and the mathematics behind histogram equalization really focus on that aspect, making that cumulative histogram much more linear. Okay, so let's explore these concepts with OpenCV. Let's open up the Jupyter Notebook. All right, here I am in the notebook from the previous lecture where we ended up calculating some color histograms for various images. I'm going to be starting off by using this rainbow image right here. So let me copy these two lines of code and come back down here, run those. So we've uploaded rainbow and show rainbow, and let's quickly check the shape. And in fact, let's reassign rainbow just so we don't mess around with it too much. We'll reassign it to image, and then let's check image shape. Okay, so we're dealing with 550 by 413 on 3 color channels. Now it's time to create a mask. So probably the easiest way to create a mask is just by using NumPy. We'll say mask is equal to np zeros, and then check check the image shape, and in this case, we're only concerned with the mask on the X and Y dimension. It's not like we're going to mask certain colors out. We just want this on the 2D plane, and then that mask will be extended to the 3 other channels. So in that case, we're only concerned with these first 2, so the shape is going to be :2. And if you take a look at this, what the actual result is, it's the same as the first 2 indices. So we have 550 and 413. So that's all this is. So it looks like a complicated command, but it's really just grabbing the X and Y components. And then next, we're going to have the mask be an 8-bit integer. And so if we take a look at our mask now, what we're going to do is reassign some of the points to be pure white. So remember right now, the mask is pure black. So if we were to say plt imshow the mask, it's a bunch of zeros, so it's pure black. And let me actually make the C map here gray so we can actually see that. So in grayscale, it's going to be completely black because they're all zeros. Now what I want to do is get a rectangle, kind of an arbitrary piece that you want to have as your region of interest, and that's what I'm going to choose as my mask. In that case, there's really no right or wrong answer as far as like what should be masked and what shouldn't be masked. That's up to you. But what we could do is take our mask and let's just take a slice of it. We'll go from 300 to 400, and then we'll say from 100 to 400. So we're taking a slice about 100 pixels along this direction, so from 300 to 400 over here on Y, and then from 100 to 400, so this block over here, so most of the x-axis there. And I'm going to reset those all equal to 255, so they're all white. And then once I've done that, let's show the results. We'll say mask, and then say CMap gray. And now you'll notice that from 300 to 400 on the Y, and from 100 to 400, now I have an area that has been masked off. And we've already seen masks a little bit with bitwise and then bitwise OR operations. And we're going to be using those same operations to essentially filter through, just on the white space, the original rainbow image. So remember, the rainbow image, if we say imshow image, this is the rainbow image. And it's actually kind of incorrect the way I'm showing it right now. I should be showing you show rainbow. There we go. So this is the color corrected. What we're going to be doing is we're going to be masking that image. So let's comment this out and then create a masked version of that image by saying masked image is equal to CV2 bitwise and we're going to pass in the image twice and then say mask is equal to the mask we created. So that is the masked image, and we're also going to create a version of show masked image. So we'll say show masked image is equal to CV2 bitwise and then we're going to pass in show rainbow twice, and then pass in the mask. Okay, so again, the reason I'm doing both a masked image and a show masked image is this one is purely for visualization purposes. That way I can visually see the correct red, green, and blue color channeling order. This one on the masked image, that's for the actual histogram calculation. Okay, so let's display what the actual image now looks like with our show masked image. And there we have it. And so now I'm only seeing this portion of the rainbow. Notice now how this portion of the rainbow doesn't appear to have that much red compared to the original image. So we should expect that our color histogram also reflects that. Let's calculate now the histogram masked values. We'll say histogram mask underscore values, and we're going to just calculate on the red channel. So we'll say CV2 calc hist. And the way this works is as a list, you're going to actually pass in the original image. So we're going to pass in rainbow. And then the channel we're looking for is the red channel, which in this case, since OpenCV, remember its default is blue, green, red, that means red is at index 2. So we'll say channels is equal to 2. And then we'll say mask is equal to the mask we created, which remember is up here. This is the actual mask object. Okay, so then we have the mask we created, and then the other parameters we're going to say are the hist size and ranges. So those are going to be the same as before. We'll say hist size is equal to 256, and then, ranges is equal to 0 to 256. Okay, so a lot going on there, but we'll go ahead and run that. And let's do one more for good measure. However, this time, we won't apply the mask. So we'll say just hist values red. So I'm going to delete that and we'll set mask equal to none, just for comparison's sake. So let's run that, and now let's actually plot these out. We're going to say plt plot, and we're going to start off with hist mask values red, and I'm going to title this, just so we can understand what we're looking at. This is the red histogram for masked rainbow. And what does the actual masked rainbow looks like? Well, it looks like what we have up here. Notice there's not a whole lot of red going on. So let's actually run this and see what it looks like. Okay, so you'll notice, just as we predicted, in this red histogram, there are very low values for red, and most of the values are actually 0. And then as we continue going on, we see less and less pure red value, so not a whole lot of red going on there. Now let's check out what happens if we were to do the same thing for the full rainbow image. Remember the full rainbow image, if we actually display it, let me just display it quickly here, plt imshow show rainbow. Remember, this one actually has quite a bit of red, including representation here in the purple area and violet area. So we're going to do the exact same thing. We're going to plt plot, except in this case, we'll do the no mask values red, and then we'll say for normal rainbow. And if we run that, notice now we see way more red over here. So we're pretty much doing the exact opposite of the masked. And that's because we can see that much more of the image is actually represented through the red channel. And that's the basics of applying a mask to a histogram. So in general, we really won't be doing color histograms that often, and when we do color histograms, we probably won't be applying a mask to any particular area. But just in case you need to understand that, basically you can always just reference the code in the notebook on how to create a mask, which we've seen a little bit of before, and then how to actually just calculate it and then pass in that mask. And this step right here of mask image and show mask image, that was kind of just an in-between step so we could clearly see what was going on there. But really, all you need to do is create this mask right here, which is essentially just creating NP0 as black and then filling in your particular region of interest with white, and then you can create the mask that way. Okay, we're going to go ahead and now move on to the main part of this lecture, which is the histogram equalization. Remember, that's a way we can display contrast.